Good afternoon, class. As promised, here I am with these problems. So you have, this is one of the problems from the test. It's similar to the one, of course, with slightly different numbers. So you have y equals 3 to the power of negative x, and we're trying to figure out where is the function decreasing. So it's a pretty interesting problem. So let's first graph it out, because that's the first thing they want us to do, to graph it out. So what you got to do is, as we've been doing in class, we make a table and we start with negative 2. For x, then we do negative 1, 0, 1, and 2. So those are our independent variables. So we are trying to figure out what is our y. So how are we going to start this? So this negative 2, we are going to plug it in for this x. So negative 2 goes in where you see an x. So you have negative and a negative. So two negatives make a positive. Well done. So you get y equals 3 to the power of positive 2, which gives you positive 9. So you get positive 9. Then you do the same thing, but now you're going to plug in a negative 1. So negative and a negative will give you a positive 3. And how about anything to the power of 0? Anything to the power of 0 is equal to 1. Good. Okay, now this is where it gets a little more interesting. So you have y equals 3 to the power of, this negative comes from the original function, and to the power of negative 1. So when it's to the power of negative 1, you do what? You flip it over, and it becomes 1 over 3 to the power of positive 1. So, which is just 1 over 3, right? So you get a pretty small fraction. Now, notice what starts to happen. Now when you do y equals 3 to the power of negative 2, you get 1 over positive 9. So you see the numbers, the fractions are getting smaller and smaller and smaller. So we are approaching what? I'll reveal that at the end of the video. Okay, so now let's graph it out. So at negative 2, you get what? 1, 2, 3, 4, 5, 6, 9. So you're here. Then for negative 1, you're at positive 3. 0, you're at 1. Then for 1, I'm just going to approximate because it's humanly impossible to have it spot on. And this, so your graph is going to look like so. Oh, I made a cardinal sin of touching that 0. I'm so sorry. So this thing is, there you go. There you go. It goes on forever, but it never touches this x-axis. Never touches that. So do you guys remember what's that word? It starts with A. What's that word for that dotted line? What's that called? Asymptote. Well done. So here, y equals 0 is your asymptote. Okay. So going back to the original question, where is this function decreasing? Where is it decreasing? You see, start with your finger. Of course, everything starts from the left. So you start from the left, all the way from the left, and then go like this. And then just follow the graph that you just made. You see your graph is going down, 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 forever. So your function starting all the way from the left. What is all the way from the left called? Negative infinity. So it's decreasing all the way from the left, negative infinity, to what? To what? So you go, it's decreasing, decreasing, decreasing. It starts to level off, But you see the fraction is still getting smaller. So it's still decreasing, decreasing, decreasing till forever. So it's decreasing from negative infinity to positive infinity. So that takes care of that. Now, let's talk about the domain and range for this graph. So what is the domain going to be? I hope you guys can see this color. So domain deals with what? X or Y? I'll give you guys a second. Good, X. Domain deals with X. So we are just going to look at our X's. Is there any X that we are not allowed to put in here? Anything that will make this guy undefined? Do you think so? No, absolutely not. So if nothing makes it undefined, then your domain is what? Is going to be from negative infinity all the way to positive infinity, right? Because any negative number is good for x. Any positive number is good for x. And 0 is of course good for x. So your domain is all real numbers, negative infinity to positive infinity. All right, what about range? Range is not going to be as straightforward here. It's not going to be all real numbers. Let me tell you that right off the bat. Why? Because look, when we were plugging in numbers here, you got 9, you got 3, you got 1, you got 1 over 3, you got 1 over 9. What's common in all of these numbers? They are all what? They are all positive. So, your range is going to be all positive numbers. But notice here, you get really close to 0. 1 over 9 is really close to 0. If you were to plug in a 3 here, what would you get? 3 to the power of negative 3, that is 1 over 27. See, you're getting closer and closer to 0, as shown by your asymptote. I'll label that asymptote. But you are not actually getting to 0. So your range is going to be 0, not inclusive. You do not include 0. 0 all the way to positive infinity. So that right there does it. So you got the domain and range, and you got the where the function is decreasing. And that's it. Thank you.